Okay, we start the third page of the 3-4 notes with something that hopefully you already know. The side opposite of a right angle in a right triangle is the hypotenuse, while the other two shorter sides are known as the legs. All right, for the hypotenuse leg theorem, if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and a leg of another right triangle, the triangles are congruent. So just like when we had side, 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 angle, all of those, we now have the HL for hypotenuse leg. Now make sure you're paying attention to this. This is the big deal. If you're going to use HL as your reason, you have 4 things to state. First, well, I guess it doesn't have to be in this order, but you need to show that you have right angles. And then, since you have right angles, you can say that you have right triangles. And then, of course, you need to state that the hypotenuses are congruent. And, of course, you have a set of legs that are congruent. So always those 4 things. People like to try to skip this one because they're like, well, if there's a right angle, there's a right triangle, but you need to state both separately. So please do that. All right, first proof. CD is congruent to EA. That is marked for you. AD is the perpendicular bisector of CE. So you've got 2 things. Perpendicular bisector means you've got a right angle, as marked here. That's the perpendicular part. And then it's also the bisector of CE, so therefore CB and BE are congruent. So we're going to have to write about that. So let's write down our givens. All right, so that is given, and then immediately following that, since the last thing I wrote was that we've got 2 things to do. The easiest one is the bisector part, so I'm going to do that for number 2. So CB is congruent to BE. That would be definition of bisector. You could say segment bisector if you want to get more particular. And then, like I said, you need to state that you have right angles and then right triangles both. So step number 3 would be that this angle here, CBD, and this bottom part of it, EBA, are right angles. And we know that because that is the definition of perpendicular. It says they're perpendicular bisector. So if they're perpendicular, they must make a right angle. And then your next one would be that those are right triangles. Triangle CBD and triangle ABE are right triangles. This is a new reason. It's just definition of a right triangle. It has a right angle, so it must be a right triangle. So if you're going through our reasons, we've got right angle, right triangle. The hypotenuses, that was given to you. That's your CD and EA. And then your leg, that came in right here with the bisector. So you have all 4 things. So now you can write your conclusion that triangle CBD is congruent to triangle EBA. And our reason is HL, hypotenuse leg. Okay, next one. This one's maybe a little shorter. They tell you a lot here. Write down your givens. All right, so they have that WJ and KZ are congruent. Hopefully you realize that those are legs. So we've got the legs, that's one thing. They told you the right angles, that's two things. So immediately following that, I'm gonna say that, let's see, these triangles, however you wanna call them, I'm just gonna name the way they name it in the proof. Triangle JWZ and triangle ZKJ are right triangles. And again, that's going to be definition of right triangle. So we've got three things here. We've got the legs are congruent, right angles, right triangles. Your fourth thing is the actual hypotenuse, if you're going to use hypotenuse leg. And if you look at this, the hypotenuse is JZ, which they share. So that's easy. JZ is congruent to JZ by the reflexive property. And then you've got all four things here that we talked about up top. So the triangles are congruent. By hypotenuse leg theorem. All right, flip the page. We'll try to knock out two more here. All right, write down what we know. And then look at your picture and make sense of it. All right, so in our picture, they tell you they're right angles. That's nice. That's one thing. They tell you SP and QR are congruent. Hopefully you're realizing that those are your hypotenuses. And so we have two more things we have to do. We need to talk about the leg, which it appears they share this leg right here, so that's easy. And we also need to state that they're right triangles. So I don't care which order you do that in. Since they already talked about the right angles, I will say that they're right triangles. Oh wait, just jumping ahead. Triangle PRS and triangle RPQ are right triangles. Same as before, definition of right triangle. It's got a right angle, so it must be a right triangle. And then we needed to talk about a leg, and we said already they share this leg. So PR is congruent to PR. We all know that's reflexive by now, right? And there's four things. So just to review, right angles, right triangles, you've got the hypotenuse, and you've got the leg. So you are good to say they're congruent by hypotenuse leg. All right, and one more. We've got lots to write for given. All right. So again, look at our picture. Start with the givens. EB is congruent to DB. That's nice. Those are our hypotenuses. So there's one box checked. It says angle A and angle C are right angles. It appears they're labeled that way. So immediately following that, we could write that the triangles are right triangles. So triangle EAB. And the other one, DCB. Are right triangles. Hopefully you've got this one down. Definition of right triangle. So we've got three things, right? We've got hypotenuse, right angle, right triangle. Now all we need is a leg. If you notice, they gave us this B is the midpoint of AC. So AC is the whole bottom, B is the middle. Therefore, AB and BC must be congruent. Definition of midpoint. So again, four things. We've got them all here. Right angles, right triangles, hypotenuse, legs. If you need to, you can write that. HHLL, right angles, right triangles. You are done after you state what you're supposed to prove. BEA is congruent to triangle BDC by hypotenuse leg. That's it.